we're going to do an example in which we use visual analysis to analyze a frame. In this case, we have a frame of 3 members. Notice from the problem statement that you have a fixed support at A, a pin connection at B, another pin connection at C, and a pin support at D. And then notice that how the loads that we have. Notice that the columns have a height of 15 feet, and that the beam has a length of 24 feet. Okay, and we have these different loads that we're gonna model in visual analysis and trying to and we're gonna obtain the same results, the same moment diagrams that you can see here. So in visual analysis, remember, change your because we're doing a 2-dimensional problem, change here the structure type to plane frame. And then we're gonna start. I'm just gonna draw the members. Usually what I do is I just draw them, and then I check on the nodes and I adjust the nodes. The first node has the coordinates of 0, 0. The second one here, it should be 0 and 15, and it's 0 and 14. So I'm gonna fix that. Then this one has to be 24 and 15. I'm gonna fix that, 24 and 15. And then this last one, it's gonna be supposed to be 24 and 0. I just need to fix this number, and then we're all set. Then I'm gonna do I always like to do the zoom all, so my frame is centralized. Maybe I can zoom out a little, and I can do the picture view, so it looks good. Again, it doesn't matter what kind of members I have for the results I'm looking for. So then I'm going to turn off the picture view, and I'm going to do now the supports. Here is supposed to be a fixed support, so I'm going to go here, and on the support here I'm going to fix everything. Okay, and then on this node here it's supposed to be a pin support, so I'm just going to fix the displacement. I'm going to leave the rotation free. Okay, now I need to have on this here I need to have here a pin connection and another pin connection here on this side. Again, there are several ways I can do this. The easiest way is I'm gonna just click on this member, and it's rigid connect. So I'm gonna do simple connect, and then these little circles here means that I have a hinge here and a hinge there. Remember only to have don't change this member so that you have another hinge here, because then the structure will collapse. Only one hinge, okay? One here and one here, and that should be enough. Now I'm gonna do the loads. Let's see the loads here. I have here a lateral load of 0.8 kip per feet. It's a uniform load on member BA on the left column. So I'm gonna click on this member, and I'm gonna right click and apply member load, and then it's supposed to be uniform. It's gonna be a force in the X direction. I'm gonna click now on, it's gonna be it has to be on the full span, and it's 0.8 kip per feet. So I do okay, and I have that load. If I need to change that load, remember I can just always just click here and then change that. And then let's see, I need 2 loads, one at 8 feet, and then another from the left side is going to be 16 feet. The first one is 6 kip, and the second one is 3 kips. 6 kips and 3 kips. 6 kips and 3 kips. So let's see. I click member load, apply member load, and then now it's going to be a single point load. It's going to be in the Y direction. And it has to be -6, and the offset it has to be 8 feet. Okay, and then I'm going to repeat that, but now I'm going to change it to 3 kips, and the offset will be 16 feet. 8 plus 8, 16. Okay, and now my structure is ready. It has all the loads that I need, but remember I have to turn off the self weight because I put everything at that load, and I don't want the program is not saying anything about self weight, so I have to turn off the self weight. No self weight. Okay, close. Okay, and I think we're ready. We're gonna do we can do the results, and we can do the here if you want to, we can check out the reactions. Okay, that will be the reactions that we have. Okay, and then let's see the member graphs. I'm gonna click on this one, and then see the member graph. It kind of looks weird. It doesn't look like what we are supposed to get, right? This is what we're supposed to look at. It's a shear diagram that goes linearly from 18 to 0, and one goes like a parabola or parabolic from 96 to 0. So it looks weird. So here you can change that here because it's treating it as a 2D column. Sometimes the program does that. It changes how you're looking at it. We can do it like a 2B. Okay. So and you can see now that we have the exactly, it's not negative 96, it's 90 here. And then you can see now we got exactly the same diagrams as that one. Okay, so you can change the way the diagram looks here. Let's say I don't want to look at the deflection, then I can just um, do not use, and then we can look at the diagrams there. Okay, and then I can do annotations here, so we can do the values. Okay, the data points, you can turn that off, so you can adjust the way the diagrams look here. Okay, then let's see if I do the other member, then I go to the member graph, and this is what it looked like. Let's see how it's supposed to look. You can see here is constant 5, then -1, and then -4, and here it goes to 40 and then 36. Let's see, it looks very similar, almost 40. I guess it's round off error there, and the shear diagram looks exactly the same. Okay, and if we do if you look at the last one, the last element, you're gonna see that the shear and the moment is 0 on that on this element CD, supposed to be 0. And then so if I go back here and I change the element, and you can see you're gonna get 0, nothing in there. Okay, so we got exactly the same results. Thank you.